Amazing. So thank you so much, everyone, for joining us today. It's really amazing to see you all in person. I'm very used to, so much of the Arweave ecosystem is online. It's been built fundamentally online, and so I'm used to seeing all of your faces on Zoom calls and in GatherTown. But it's nice to actually, realize you all have physical bodies as well. Okay, so today I'd like to talk to you about something that's really fundamental to the Arweave network, I think. It's the mechanism through which we achieve permanence in a fundamental way. What is Arweave in the first place, right? It is a permanent information storage system at its core. It does lots of other interesting things that we'll hear about today, and there are lots of ways that you can use it, but fundamentally it exists to store data as long as feasibly possible. We have, since the beginning of Arweave, seen that goal as trying to make the data outlast the last human-like thing. When we say permanent data storage, like, we're not messing around, we're not trying to use it as marketing. It is sincerely the effort that we're all attempting to make together. And we think that there's only really one way that you can possibly attempt to do something like that, and that is to produce a system that is open source and has a risk model that is public and transparent, and a mechanism through which everyone can audit and validate the system. I can't make you a promise, and I wouldn't want to make you a promise, and nor would I want you to believe me or anyone else. I would like everyone to understand how the system works at a fundamental level and assess its merits for themselves. So with Arweave 2.6, which is the latest version of the network, which the hard fork activates on, I think it's March 6th, 3 or 4 days now. It's pretty exciting, yeah. We've got the technology of the system, you could say, concrete implementation of Arweave today to a point where I think it solves every problem that we can currently foresee. It is useful and it is scalable, and when I say scalable, we don't mean like, trust me bro, it's gonna be fine, we're gonna put roll-ups on it, and then, yeah, you're gonna, I don't know, now I'm paying 30 cents to mint an NFT, and no, I don't mean that kind of scalable. I mean actually, like, you just throw more data at it, and it doesn't increase the fees. So it scales arbitrarily. That's pretty good. We're now up to nearly 600 million pieces of data stored in the system. People evidently find it useful. The system is fast. If you use a bundling service on top, you can get instant access to your data with a guarantee that your data will be written. There really aren't any open questions with the fundamental technology as we understand it today. It's all transparent, you can go look at it, you can go understand it for yourself. But there is one thing that we know that we can't know, and that is that the future will be unpredictable. There will be things that we can't possibly know today that will happen. And so we have to have a mechanism inside the network that lets us adapt. And since the beginning of Arweave, we've always had this process of forking as a sort of a fundamental adaptivity system. But the problem with that I'll get into later is that it doesn't have incentives. So today we're very excited to launch a new mechanism inside the Arweave ecosystem that we call an evolutionary protocol. There's a lot of sort of detail to it, but I think that the right way to start this is to look at, well, what are the other options? Like, why are we here? Why are we looking at something new? And the other options are basically in the forms of DAOs and forks. So forks were the system that started the blockchain kind of open, transparent network revolution, what now, 14 years ago, 13, 14 years ago, I guess. It's the native governance mechanism, if you want to call it that, although I don't think that's quite the right word, of Bitcoin. And then after that, we created these things called DAOs, right? Decentralized autonomous organizations. And they are the mechanism that's been used most recently, I'd say, in large volume. So we'll look at that first. I'm actually going to move this chair here. Okay, so DAOs. What's the basic idea? Well, they're decentralized autonomous organizations. They're programmable ways of orchestrating human behavior. But in their concrete implementation at the present time, they almost always look like a coin voting system. So people have tokens inside a network or a smart contract, and they can vote with those tokens on which proposals they want to approve or not. let's look at, I'd say, probably the biggest or second largest DAO in practice, which is MakerDAO. They handle a treasury of about $6 billion, and they've been running, actually Maker, interestingly, started running before Ethereum mainnet, I think, in 2014. They launched the protocol in 2017. But I think that there are some really fundamental issues that are sort of highlighted by the history of MakerDAO in practice, not the ideals, but what actually happened when people started executing it. And I'm not picking on Maker because they were particularly egregious. It's actually the opposite. I think Maker is just an archetypal example of the problems with these systems. So Maker got started. It was a DAO that offered a decentralized stablecoin. So the idea was, let's take the censorship resistance and immutability of Bitcoin, but let's solve the problem that the price of the token fluctuates all the time, so you can't use it for contracts. That's a pretty intelligent idea, I think, is actually a great idea. But in 2019, they changed the idea slightly, and they said, okay, well, single collateralized DAI, so a stable coin backed by a single asset that had a floating price, which was Ethereum, was okay, but why don't we add multiple collateralized DAI? Why don't we make it so that instead of just having a treasury of a single token, we can have many different tokens? It sounded sensible, and this was an upgrade that the community had to choose to opt into, right? So they had the choice at this time. They created this new contract, and they called the old, well, Andrew, maybe you can help me with the, there we go. Okay, thank you. All right, so yes, they took the old DAI and they called that SAI, single collateralized DAI. Fair enough, and people chose to upgrade. And at this point in time, DAI was used across the Ethereum ecosystem for virtually everything. It was the medium of exchange, and for good reason. It was a censorship-resistant, immutable asset that didn't change its value. It's a very, very cool thing. And that happened in November 2019, this change to multi-collateralized DAI. And when they did so, they announced that, you know, in this blog post that, we're going to use all of these other censorship-resistant assets. And so, okay, makes sense. It just sounds like a better version of the protocol. So people upgraded. But part of what this did, it turned out, was delegate a large amount of control to the MakerDAO DAO. And it was only 4 months later that they approved the addition of USDC as a backing for DAI. So the problem with that, of course, is USDC is just a centrally issued stablecoin. So anyone can come along to the issuer circle and say, please don't let these tokens be redeemable. They are censorable tokens. And so as a protocol that was supposed to give its users certain immutable rights, now those rights started to shift. But okay, you know, it's all on chain, and there's only a small amount of USDC, so I guess it's not so bad, right? Well, then it got worse, and it got really far worse, actually. They ended up in a situation where most of the collateral was in these centralized stablecoins, and then they started depositing those centralized stablecoins into centralized exchanges to earn yield on top of them. And that yield would be taken not by the people that were holding DAI, but the people that were holding Maker. So this is a massive, massive deviation from what the protocol was supposed to be about in the first place. And the scary thing is, if you were a user or a developer that had integrated that protocol into your system, you were dependent upon it in some form, you had no real way of stopping this happening. It was going to happen with or without you. That, I would say, is a fundamental breach of what blockchains are about in the first place. You know, Bitcoin is the opposite of this. It is an immutable, censorship-resistant asset. And that's why about a year ago, Ukraine started offering Bitcoin as a reward to Russian soldiers that defected. It's a neutral asset, provably neutral. You just can't do that if you're backed by a DAO. And Arweave, I think, is it's a potentially even greater sort of risk in this vector, because information is something that people argue about what information should be stored, what information should not be stored. And they have been doing this and perpetuated and spread. They have been having this debate for, Well, since we created paper, basically. Like when the Bible started spreading, people had opinions about whether that was a good idea or not. And it's happened essentially at every technological progression since then. So if we were to have a council of some sort that was in place to govern parts of the protocol, I think that would put the mission of the thing seriously at risk. So, okay, that's not an option. What about forks? Well, Arweave is a fork-based system. It has been since the day that it launched. And in fact, the system that I'm launching here today, you can just choose to ignore it if you want to, because it's just a modification. Well, your rights are preserved as a user of the system, and what we're talking about are just forks on top of it. So essentially, you end up with this situation where someone could come along, for example, and say, hey, I can make Bitcoin better, and they could make Bitcoin that has, I don't know, faster block times or something like that. But you are not forced to use it. And Arweave is just like this at the fundamental level. There's nothing I can do to change the Arweave protocol, or you, or anyone else. The whole idea is that it should be full and transparent and immutable. And if people want to modify it, they can make what is essentially a duplication. You don't modify Arweave, you duplicate it. But there's a problem here too, which is that the forks are not incentivized. So let's imagine that 100 years in the future, there was a major problem with Bitcoin. There was some flaw that no one had realized until later, and now suddenly we needed to solve it. Well, because Bitcoin has this immutability and it doesn't have incentives to mutate it, you end up with this situation where only a small number of people are incentivized to do that. And it works like this. They have to make this expression positive. So you have to own a sufficiently large amount of the protocol such that the improvement percentage, say, that you need to add to the network, or that you're able to add to the network, minus the expenditure that it's going to cost you to make that improvement, is positive. So let's imagine that you own, say, $1 million worth of the tokens in the system, and you can make the system 20% better. Okay, and it's going to cost you $100,000. Then you can just about make this expression positive. But in the case of Arweave, the number of people that own $1 million of Arweave or more is 77 or fewer. That's not very many people. It's a plutocracy. So, and when we look at the history of forks in the Bitcoin network, we actually see that this is exactly what happens. The only people that are willing to put the effort into trying to improve the network are people like Roger Ver, right? And say what you will about Craig Wright, but we know that he has more than $1 million of Bitcoin. I think it's pretty clear that he was an early Bitcoin miner in some form or other. These are the people that have enough of an incentive to actually try and improve the protocol. But they're vanishingly few. And what's really depressing about this situation is that if you think about how, say, Bitcoin and Ethereum, and it's also true for Arweave, got started, they were started by people, at least with Satoshi, we don't quite know for sure, but I think all the evidence points to the fact that they're started by people that don't have huge amounts of resources on hand. Right? So when Vitalik got started building Ethereum, there was really very little that he had on hand to help him with. And so if you just, say, imagine that you even have $1,000 worth of the tokens in the system, you can make it 20% better, and you somehow manage to borrow the $200,000 that it costs to try and actually improve the protocol, well, then you're going to end up at minus 199.8K. Like, you've made $200 and you've lost 200,000. It doesn't make any sense. It's not a viable system. So that's why we're excited to launch today the framework for evolving Arweave. And fundamentally, this is a system that is a simple modification of the fork-based approach to blockchain governance, but with the addition of allowing people to claim a reward for doing so. And then the market determines how that reward, how much that reward is essentially worth eventually. So let's look at a worked example. So there's the Arweave original version. And I want to be clear that we, so at Forward Research, as well as the Digital History Association, and there's also another group in the ecosystem that recently committed to working on the core Arweave implementation. We will do this for the next very long time. Like there's this system really should only kick in, I would say, in the years to decades or even centuries sort of time span. But if we are trying to build a system of permanent information storage, we have to have something that's going to let us to adapt to a problem that emerges 270 years from now that's completely unforeseeable today. So the, let's say, original Arweave is running, and then a problem emerges in the environment that no one predicted. Then innovators can come along and they can say, okay, well, if I solve this problem for the network, I can claim a reward. And more than one person comes along and does this because there is an incentive to do so. And essentially what you end up with is a market. So they've created their new versions of the protocol through research and development. They've claimed a new reward of some sort inside that protocol. And now the market can decide. There's essentially 3 Arweaves. You can say, okay, with your feet, if you will, with your tokens and with your data usage in the network, you can decide which of these forks you think is best. And by doing so, you increase and decrease the prominence of the other forks. So there's a market mechanic here that is trying to work out which is the best evolution of the system. And so in this particular example, say, A comes out on top. People really decide that, okay, first question, is this actually a genuine problem that we're trying to solve? If the answer is yes, then which of the solutions are the best? Well, let's say A. And then the third question, is the reward that the innovator is claiming fair for what they've added? And the right way to think about that is kind of like fundraising in a startup. So say you have some equity in a startup. Well, you might want the startup to create some new tokens to give to new investors so you can invest in the value of the startup such that all of the equity increases in value. You essentially want to take the dilution because more value is being created. And we're sort of showing that here with the size of these pies. So the innovator takes a new slice of the pie, but the size of the pie increases. Now, a fundamental thing to notice about this is that the original Arweave is still there. You can still keep using it. Or, 500 years from now, it's not the original Arweave, it's some other derivation. Well, no one can force you to upgrade. If you and a small number of people still think that it is the right way to do things, you can continue to organize yourself in that fashion. There's no, if you would say, like, drag along rights to the governance. You are sovereign in the system, fundamentally. It's your choices that matter. Another very interesting thing that this allows us to do is say, okay, well, we have this evolutionary tree of different versions of the protocol over time, which are rewarding innovators for taking part. But they could even take those protocols and modify them such that they actually address new niches. Like, the thing that is Arweave is a permanent information storage system, but there are other useful systems out there, right? Like, you could imagine modifying the system to support temporary data storage. And so you'd essentially create a new niche. And that's really interesting because you can sort of, as a community, as we find things interesting, we can spread out and, explore them and use the different protocols that emerge. And as an innovator, you're incentivized to do this because instead of just starting again from scratch and starting with no community, you can just claim a reward, and that reward is not capped. Only by the market is it determined. Yes, and instead of competing, you can sort of bring that energy inside the system and make it pro-social. So you don't have to compete anymore with people, you just add value and you can claim a reward for adding value. Why is this so interesting? Well, because we're trying to build a system that stores data literally permanently. And there really aren't very many systems that have lasted for, tens of thousands of years. But one of them that has is evolution. Evolution was the thing that brought us from single-celled organisms all the way through to the humans we are today. It's profoundly good at adapting to unforeseen situations in the environment. Yes, and making things survive, fundamentally. And so what we've done with this mechanism is bring evolution inside the social protocol around Arweave. So, well, how do we actually implement this? This is not like a piece of code. There's zero code here. It's the wrapper, the social wrapper that sits around the network itself. And there's a reason for that. It's that the whole, would you say, contents of the, or not the contents of the network, the technical framework of the network can be replaced every time that there is a new innovation or an evolution of the system on top of it. So you can't write it in code because the code itself will change. Instead, it's far closer to something like a constitution. It's a simple written document. It's, in fact, I'll show you. It's 261 words. Oh, can't see the top. That's a shame. Well, this is a good way to reason to use the QR code here, which if you scan this, you can read it on the permaweb, of course, and also you can stamp it if you'd like. You can show that you were here at the birth of this new mechanism. Yes, so it's a very simple document. In essence, it's really just a set of rules for innovators and a set of rules for community members. The first rules for the innovators are you must include every byte from the previous version of the protocol, right? You have to be an honest part of the lineage of permanent data storage systems. You must include all of the tokens from the previous part of the protocol. And then you can create a new reward for yourself. But you shouldn't create too much because the market will then see that as, would you say, inappropriate, and will just sell all of your tokens. So you can mint as many as you want, but they'll be worthless. So you have to be reasonable about that. And the market pressures ensure that you get a good reward, but not excessive. And then there are rules for community members for adjudicating these forks. And I think that because of the history of Bitcoin, you know, there haven't really been any forks of Bitcoin that were successful. And I think that's because all the forks were essentially low effort. Like, they weren't really trying to solve real problems, or problems that weren't solvable through other sort of, let's say, less invasive means. And when we talk about forks, in the Ethereum community in general, actually, we're talking about what we would call state resetting forks. So you take the code of a protocol, like say Uniswap, and you start it again from scratch, like SushiSwap. And this is a result, I think, of those incentives that I was describing, or lack of incentives in the core basic forking system, which say, well, look, you can't really gain a reward for making an improvement to the protocol as a normal fork. So what you have to, or what people are forced to do, is just start again from scratch, which of course with a permanent data storage system is a disaster. Like, we can't have a situation where everyone is starting again from scratch every 100 years. Like, we need to create a lineage of protocols. And so what I would argue for is that our community sees that forks like this, evolutions of the protocol, shouldn't be greeted with overwhelming excitement, but they should be greeted with skeptical optimism. Look at it, assess it seriously. Is it actually an improvement on the protocol in a base sense? And be welcoming to it in some regard. Yes, so there's a set of processes that community members really need to, I guess, take part in as well, which are kind of outlined at the end of the document. Okay, so why is this something that we're really excited about? I think there's really 4 core reasons. It's a mechanism, and this is the QR code if anyone still wants to scan that. It's a mechanism that allows us to adapt the protocol to unforeseen situations which will inevitably arise while maintaining user rights. It plays into the structure of making an open, transparent system with immutable rules that you can assess for yourself. Like, the whole idea of Arweave is that it's a risk model to some extent, but you can look at how it works and you can decide on your own whether you trust it or not. And that makes you sovereign. It's not that you're depending upon the actions of others or the promises of others. And that, to some extent, is with the case with DAOs. If you have a DAO, like MakerDAO, and for example, if we'd implemented I don't know, stable coins in the endowment or something like that, and we'd back that with DAI, you can imagine a situation where now we're dragged along and we have to trust that the DAO is not going to screw that up, which they frankly did. It's a bit of a nightmare. So we've got a fundamental solution to that problem in this system. But deeper than that, what this mechanism does is it empowers individuals or very small groups to iterate on the protocol and improve it in order to gain a reward, rather than having governance by committee, which, when you think about it, is really not surprising that what we've seen with the large DAOs is that they come to resemble large corporations. They're handling treasuries of, like, I think DAI is at $6 billion now. You sort of want an institution like that to be risk averse, but it also means that they're not going to innovate. And with Arweave, we have a radically different situation. We say, look, if you are an individual and you think, no, I can make this system better, it doesn't really matter. You don't have to convince people in endless governance proposals. You just go do it. And then you ship it and you put it out there and you say, hey, look, see, it works and it's better. And over time, people will come to realize that and they will move to using that version of the protocol. This is a system that empowers individuals over committees. And I think that's over time, that will play as a really important part of the mechanism. Again, unlike DAOs and well, that's a little bit complex, but to some extent, normal forks, this creates a system for a market for improvements. And one of the important parts of this is that if you have a committee deciding something, they are naturally going to decide on the information that is available today. How else are they going to do it, right? But humans are pretty bad at working out what's going to happen in the future. Whereas this system says, no, if you've got a hunch that in 5 years there's going to be this major catastrophe, and you put the time into producing a new version of the protocol, you create a reward for yourself for doing so, and then you avert the catastrophe, and the catastrophe plays itself out on the other fork, people will come and they will use your version. And so we can run multiple of these experiments in parallel, essentially. And we don't have to have this situation where a committee of risk-averse people who you have the principal-agent problem, it typically becomes kind of political, trying to decide how to innovate on something that is still relatively early stage. Frankly, everything in crypto is early stage, yet a lot of these protocols are governed like they're 50-year-old corporations. They're extremely slow, extremely risk-averse, and they're poor at really innovating on the protocols in a passionate way. Here we're empowering individuals to go do that for the protocol. One final thing that I'm particularly excited about, and this is kind of hard to explain, I don't have the right words for it, but I'll try. This system turns competition into collaboration. I think the right way to understand this is to think that, okay, well, Maker, for example, may have a governance system, right, inside it. But because they were, I say, derelict of their duties, the market created an incentive for someone to make something that was actually fulfilling the original vision of DAI. They called it RAI. And now the market is the true governor. The market says, well, should the resources be allocated to DAI or RAI? And that is changing over time. And so, that is true in every area of capitalism. It doesn't matter what the governance system of your company or your DAO or your protocol is, when it exists in a framework where the market will incentivize other people to create competing products, and then it will decide how resources should be distributed between them. The market itself is a governance mechanism. And what this system that we're putting forward here does is it, would you say, brings that inside the governance system of the protocol itself. It says, well, look, you can, instead of starting again from scratch, you can take the existing permanent information storage system, you can mutate it in some way that you believe is better, and then that can compete with the original. But you can do that in a pro-social, collaborative way. Now your competition is actually benefiting everyone. I think that's a pretty profound shift. Okay, so as well as the core document, there's also a sort of longer document, it's about 6 pages, which outlines how each of the rules work and the emergent behaviors that they should create. You can check it out at this QR code. Also on the Digital History Association Twitter, there's now, there'll be links to that right now, hopefully, or at least later in an hour or so. Yes, so this document takes you through everything you need to know to understand how the simple rules interact with one another to create the outcomes that we want. Okay, so thank you everyone for listening. I'm really appreciative, particularly of all of the people that gave us support and feedback and endless, endless and rigorous debate through the process of making this. There's really, we produced a paper. So we started thinking about this about 18 months ago, maybe 2 years approximately. And we started talking to people in the ecosystem and trying to discuss or iterate on this question of how would we structure something like this, I guess. And that culminated in this paper we produced late last year called Fair Forks Towards Incentivized Protocol Governance. And you all gave amazing feedback on that. I was extremely grateful. And that is was the impetus of what drove us to the point that we're now at, where we finally have something that's actually robust, and rigorously, battle-hardened in the thoughts of the ecosystem, I suppose. So I'm really grateful for all of your help getting to this point. It's been quite a road. Okay, thank you so much, everyone.